Hi everyone, welcome back to our channel. So today we are going to solve how to find the power factor for an series RL circuit. So in order to understand this, let's try to draw the basic diagram. So we already drawn the power triangle for this series RL circuit. So from the power triangle, already we know that S is equal to P plus JQ. I mean, what it indicates is this is P and Q is displaced with an angle of 90 degrees. Therefore, we are going to get an horizontal component which is active power P is equal to V into I cos phi, which is a horizontal component, and q is displaced with an angle of q is equal to, which is rotating in counterclockwise direction, develops 90 degrees, and this will constitute q, where the vertical component is vi sin phi. So the power factor remains same for series RL as well as RC also, and this is the angle obtained between P and Q, and this is the apparent power S. So from here you can write down, so this is like a complex number which is in rectangular form. So whenever it is in rectangular form, we can also express in polar form. Okay, the polar form is, the magnitude of the polar form is root of p square plus q square with an angle of tan inverse of imaginary part is q divided by p. Okay, that's how to represent the power. So here we need to find out the power factor. Okay, how to define the power factor is, power factor is nothing but a cos phi, it is defined, which is nothing but, what is cos phi? This is opposite side, this is adjacent side, which is nothing but p divided by the hypotenuse is s. So it is a factor which divides active power by apparent power, where p we can write down it as vi cos phi divided by s, we can write down it as v into I. Vi will get cancelled and you are going to get cos phi. And this power factor ranges from 0 to 1, where 0 is the minimum value and 1 is the maximum, and 1 is called as generally unity and 1 is called unity power factor. Okay, so cos phi is nothing but a factor. So this is a factor, and this factor is multiplied with s, where s is called power. Therefore total it is called power factor, and it ranges from 0 to 1. Generally, in lab, we consider it as 0 to 0.5 and 0.5 to 1. 0 to 0.5, to measure this power factor, we use LPF type wattmeter. To measure the power factor from 0.1 to 5 to 1, we use unity power factor type wattmeter. This is how the power factor is measured with the help of equipment. So this is how we call it as, this is a factor by which the apparent power is multiplied. The apparent power is multiplied how many times? Cos 5 times, to give the power which is nothing but P. That's why it is called factor. Factor means like a multiplier. This multiplier is multiplied with power. That's why this is called factor into power, which is called power factor, to get a value of 0 to 0.1. In one more case, we can define the second definition as, so this is the phase angle between voltage and current. Let us try to understand. Voltage is, let's try to take a small problem and let's try to understand. Voltage is given to me as 106.0 at an angle of 50 divided by current is 3.53 at an angle of minus 25. So this is V by I. So this I can add down, V at an angle phi 1. This is I at an angle phi 2. So how to write down this one is, V by I is called Z, and this I can write down it as phi 1 minus phi 2. Same I am applying here. So when you perform 106 by 3.53, then you are going to get 30 at an angle of phi 1. Phi 1 is how much? 50 minus of, okay, so this is in minus. Okay, so when it goes to the up, which is nothing but 50 plus 25 is nothing but 30 at an angle of 75. So this is how to find this value. So therefore cos phi is the angle between, so it's nothing but the phase angle between voltage and current. Cos of phase angle, what is the phase angle here we got? So here it is, phase angle of voltage is 50 minus phase angle of current minus 25, which is nothing but cos minus into minus is how much? 75 degrees. Or directly the phase we can write down from the Z. What is the angle provided by the impedance, which is nothing but cos 75 degrees. When you perform this cos 75, we are going to get the power factor. Okay, so this is how to find out the power factor of a given system. So this we can generally write down as phi 1 minus phi 2 or Z at an angle phi. This phi directly substitute in the case of phi here, then automatically you can find out power factor. You will get it out. What is the range of power factor? It varies from 0 to 1. This is how to define a power factor with respect to a series RL circuit. I repeat it again. This is the angle between voltage and current, and this is the ratio of active power divided by apparent power. Where cos phi is called, since it is dividing, this is called factor. This factor is multiplied with power. That's why this is called power factor. Ultimately, to result a value called as P. So this is how to define the power factor. If you can understand better with a problem, so generally we can Z, we are going to write down Z is equal to, let's take V at an angle 0, I at an angle of minus 5. Okay, so this V by I can write down it as Z. So this 5 goes to the numerator, which is nothing but 0 minus of minus 5 is nothing but indirectly Z at an angle phi. When it goes up, automatically you can write out Z phi. So this phi you directly substitute here, then automatically you can calculate the power factor. This is the importance of power factor and how to define a power factor with respect to a triangle, where this triangle is called power triangle, and where this value we are going to get is called as power factor. So hope you are able to understand. We'll try to solve another problem in series RL circuit. If you feel my explanation is good, give a like to a video and subscribe to the channel for more updates on the problem on circuits. And if you have any doubt in this concept, let me know in the comment section. And if you are watching this channel for the first time, subscribe to my channel with the name KV Tulsira. So kindly support this sort of a free channel for the development of students and faculty. We'll meet in the another video. Yours Ram.